Now let us see the students. Next is, there are two examples. One is example 6.8 and another is 6.9. If you read it, then as it is given in 6.8 example, there is a one car of mass 1000 kg is moving with a speed of 18 km per hour, and it is colliding with a spring which have been kept on the horizontal surface and having the force constant K equal to 6.25 into 10 raised to 3 Newton per meter. When the car come to the state of rest position, then how much be the maximum compression in the spring would occur? So as given in the example, mass of car 1000 kg, speed is 18 km per hour. You can convert it into meter per second, replacing kilometer by 1000 meter, in denominator 1 hour by 3600 second. If you solve it, you will get it is 5 meter per second. So 18 km per hour equal to 5 meter per second. And also you be remember, this is very useful. 36 km per hour equal to always 10 meter per second. So you be remember that multiplicative table of 18 on the another side, multiplicative table of 5. 18 ones are 18. On the another side, 5 ones are 5. So 18 km per hour equal to 5 meter per second. 18 twos are 36 km per hour. On the another side, 5 twos are 10 meter per second. That means 36 km per hour equal to 10 meter per second. 18 threes are 54 km per hour equal to on the another side 5 threes are 15 meter per second. So 54 km per hour equal to 15 meter per second. Similarly, 18 fours are 72 km per hour equal to 20 meter per second. 18 fives are 90 km per hour equal to 5 fives are 25 meter per second. So be remember this conversion. For such constant of spring K equal to 6.25 into 10 raised to 3, then you have to determine maximum compression in a spring. So as the car is moving on a smooth road, there is no any other forces are acting. As the smooth road is there, you can consider that there is no force of friction. And when the car is going to be colliding with such a spring which have been held with its one end with this vertical wall, then what will happen here? The spring goes on being compressed, and as soon as the car comes to the state of rest position, there will be a maximum compression in the spring, and at that time entire kinetic energy of the car have been converted into the potential energy of the spring because the spring have been compressed. So you can write directly here, at maximum compression of the spring, in the absence of frictional forces, kinetic energy of the car gets converted into potential energy of the spring. So you can directly write kinetic energy of the car equal to potential energy of the spring. So 1 half mv square equal to 1 half k instead of x, as there is a maximum displacement or maximum compression of the spring, to xm square. Substitute the value. 1 half mass is 1000, speed is 5 square, 1 half 6.25 to 10 raised to 3 xm square. You will get 25 equal to 6.25 xm square, because 1000, 10 raised to 3 cancel, 1 by 2 cancel, 5 square is 25, 6.25 to xm square. So xm square equal to 25 upon 6.25. Therefore xm equal to square root of 25 upon 6.25. 6.25 मतलब 625 upon 100, 100 ऊपर आएगा. And यहाँ पे 625 is a square of the 25, so 25, 125 cancel. So 100 upon 25 is there. Answer is 4. The square root of 4 is 2.0. It means maximum compression of the spring will be equal to 2.0 meter. Then in the same example, slight modification is there. Now as it is given in your textbook, consider the road is not a smooth road, but it is a rough road. And on this rough road, now the car is moving with the same speed. and then it is colliding with this spring which have been held horizontally with its one end is fixed with this vertical wall is there, and as the road is rough road, there is no smoothness, there will be a certain frictional force is there, and due to frictional force there will be a coefficient of friction. So consider the coefficient of friction of the road is 0.5 and calculate again the maximum compression in the spring. So now you have to consider the roughness of the road. Due to roughness of the road, as the car is coming from this right side, on the tire of the car, due to this roughness of the road, in the opposite direction the frictional forces are acting, and due to frictional forces are acting, now here certain part of kinetic energy of the car is going to be converted into heat energy. So due to frictional force comes into existence, and frictional force are non-conservative forces. Frictional force are non-conservative forces. You can write here, there is some another concept. So here in the presence of the friction, both spring force and frictional force act. तो यहाँ पे कार के ऊपर इस डायरेक्शन में क्यों स्प्रिंग कॉम्प्रेस होती है, तो इस डायरेक्शन में स्प्रिंग फोर्स भी लगेगा. एट द सेम टाइम कार इस तरह से आ रही है तो अपोजिट डायरेक्शन में मतलब इसी डायरेक्शन में फ्रिक्शनल फोर्स भी लगेगा. तो फ्रिक्शनल फोर्स Fs इक्वल टू म्यू mg विल बी देयर, एंड स्प्रिंग फोर्स इक्वल टू k इनटू xm is going to be acting in the direction opposite to that of motion of the car. So both the forces are acting so as to oppose the compression of the spring. So now here at this time what you have to do? You have to apply the concept of conversion of kinetic energy into potential energy plus heat energy. So be remember, at the maximum compression of the spring due to frictional force present, kinetic energy of the car gets converted into potential energy and heat energy. And heat energy is nothing but work done by the frictional forces. Work done by the frictional forces against the motion of the car. Against the motion of the car. That's why this kinetic energy equal to potential energy plus this is the heat energy, and heat energy equal to work done by the frictional force against the motion of the car. That's why this frictional force multiplied by displacement. So frictional force is mu mg. Kinetic energy is 1 half mv square. Potential energy is 1 half kxm square. So this frictional force mu mg, how does it come? So actually you will study in the lesson number 5. Coefficient of friction of surface is equal to maximum static frictional force upon normal force. So what is normal force? Normal force according to Newton's third law of motion will act on the body in a direction opposite to that of the real force acting on it in downward direction. So as the car is here, gravitational force from its center in downward direction acting, at the same time the surface of the road applying the force according to Newton's third law of motion in vertically up direction, that is opposite to that of this mg, and it is the normal force. So this normal force is balanced by mg. So here you can write n equal to mg, and coefficient of friction mu is equal to frictional force Fs upon n. Therefore Fs equal to क्या मिलेगा आपको? mu into n, but n equal to क्या है? mg. तो mu mg is the equation of the static frictional force, and this static frictional force, even though acting, the car is experiencing a displacement in this direction, so maximum displacement of the spring is xm. So force into displacement is work, and work is equivalent to energy, but this energy is known as what? Heat energy. So now solving this one, तो ये 2 यहाँ पे जाएगा तो twice mg mu x, then k xm square plus twice mu mg xm, ये minus mv square इधर ले लो तो minus mv square equal to you will get 0. So this equation is just like as the quadratic equation which you have studied in 10th standard, ax square plus bx plus c equal to 0, where a, b and c are constants, x is variable, so its solution x equal to minus b plus or minus square root of b square minus 4ac upon twice a. If you compare this equation with this one तो आपको मिलेगा constant a is equivalent to k, constant b, तो यहाँ पे x वेरिएबल था तो यहाँ पे कौन सा वेरिएबल है? xm वेरिएबल है, तो xm के साथ है वो constant b, तो twice mu mg is equivalent to b, एन कांस्टेंट यहाँ पे सी, तो यहाँ पे सी के जैसा कौन सा है माइनस एम वी स्क्वायर, तो सी इक्वल टू माइनस एम वी स्क्वायर एंड सब्स्टिट्यूटिंग दिस वैल्यूज ए बी एंड सी इन दिस इक्वेशन एंड इंस्टेड ऑफ एक्स you can extend the maximum displacement is minus b, that is minus 2 mu mg. Now we consider here only the positive sign, square root of b square, so 2 mu mg का square 4 mu square m square g square minus 4 a की value k and value of c, तो c is minus m square minus minus plus, तो minus 2 mu mg upon 2 k के बदले में a, तो यहाँ पे minus 2 mg plus square root of 4 mu square m square g square plus 4k mv square. अब यहाँ से 2 स्क्वायर रूट से बाहर आएगा क्योंकि 4 का स्क्वायर रूट 2, तो 2 बाहर आएगा, यहाँ पे भी 2, तो 2 कॉमन, नीचे भी 2, तो 2 कैंसिल, तो आंसर इज xm इक्वल टू माइनस म्यू mg प्लस स्क्वायर रूट ऑफ म्यू स्क्वायर m square g square प्लस k mv square अपॉन ओनली k. You substitute all the values. What is mu? Mu is equal to 0.5. Mass of the car is 1000 kg. Value of g you take 10. Again इसमें भी mu की value 0.5. Mass is 1000. G की value 10. Plus k. K is force constant. 6.25 to 10 raised to 3. Mass is 1000. Speed v is 5 meter per second. Again नीचे k की value 6.25. You solve it. You will get the answer is minus 1.35 meter. Minus sign says it is in this negative x direction. But displacement is how much? Maximum displacement or maximum compression. Maximum compression of the spring is 1.35 meter. So in the presence of friction force, this displacement or maximum displacement or maximum compression of the spring is 1.35. While in the absence of the frictional force, that maximum compression was 2.0 meter. So this is the difference. Now let us see a modification in work energy theorem. So last time we have studied the work energy theorem, W equal to delta K. What is W? W is the work done. किससे work? Work done by conservative force. And delta K is what? Change in kinetic energy. So now we remember, if only conservative forces are acting on a body, then work energy theorem can be written as W equal to delta K, where W is the work done by conservative force. So you can write W is equal to force into displacement. I put the symbol of conservative force is Fc, so Fc into delta x. But if only one conservative force is not there, but additionally non-conservative forces are also be there, like frictional force. So conservative force plus non-conservative forces, when both the kind of the forces are acting on a body, then you have to make a slight change, or you have to make a slight modification in the statement of work energy theorem. But if two forces, one is conservative force Fc and another is non-conservative force F and C, like frictional force, are acting on a body, then work done by them is W equal to, so work done by them equal to sum of the two works. One is work by conservative force, another is work by non-conservative force. So W equal to क्या? Fc into delta x plus Fnc into delta x. So in this equation, W is replaced by the sum of these two. And work energy theorem can be modified as W equal to delta K. But at this time, W is not simply equal to Fc into delta x. But this W is equal to Fc plus delta x plus Fnc into delta x equal to delta K. But we know that work done by conservative force Fc into delta x, barabar, Fc into delta x is the work done, and it is due to conservative force. And we have studied this work done by conservative force is equivalent to negative of the change in potential energy, because we have studied earlier change in potential energy delta K, change in kinetic energy delta K equal to minus of delta V. That's why here you can write this Fc into delta x equal to negative of the change in potential energy. So substituting this Fc into delta x equal to minus delta V, so minus delta V plus Fnc into delta x, bring the minus delta V from left to right side. So Fnc into delta x equal to delta K plus delta U. But we know the sum of the change in kinetic energy and change in potential energy is equal to what? The sum is equal to change in mechanical energy. So Fnc into delta x equal to what? Delta E. So delta E is the symbol of change in mechanical energy. So thus change in mechanical energy, that is delta E, equal to final mechanical energy minus initial mechanical energy over the whole path of a motion is equal to the work done by the known conservative force. So this is a new statement. The work done, or you can write the change in mechanical energy over the whole path of the motion is equal to the work done by known conservative force. यहाँ के WNC equal to, you can write delta E. So this Fnc into delta x is the work done by known conservative force, is replaced by the symbol WNC. So you can write here WNC equal to delta E is the mathematical equation of work energy theorem for known conservative force. So whenever the known conservative force is there, then you can write WNC equal to delta E is the statement of work energy theorem. But we remember that the work done by conservative force, we have studied that. What was the conservative force? Conservative force is the forces during which the work done does not depend on the path along which the particle is moving. Whether the particle is moving along straight path, coming straight down, or it is going along this kind of the curved path and then coming down. So it does not depend on the path. We remember the work done by conservative force does not depend on the path. लेकिन जब नॉन कंजर्वेटिव फोर्स होता है तो पाथ पे डिपेंड करता है, बाय कौन सा पाथ? ज्वाइनिंग इनिशियल पोजीशन एंड फाइनल पोजीशन. बट द वर्क डन बाय नॉन कंजर्वेटिव फोर्स, दैट इज WNC, डिपेंड्स ऑन द पर्टिकुलर पाथ फ्रॉम इनिशियल टू फाइनल पोजीशन. And then we have to study about the next topic of this chapter. It is the various forms of energy, different forms of energy. In physics you will study there are a lot of kinds of the energy are there. Which different kind of energies are there? As here I have written, the first one you can say electrical energy, heat energy, chemical energy, equivalence of mass and energy, nuclear energy. There are a lot of energies there. But here in physics we have to study about all this kind of the 5 kind of the different energies. So first we discuss about the electrical energy. Now electrical energy, which one electrical energy? At present you are always be enjoying the modern facilities like AC, TV, fridge, mobile, etc. So this is due to what? This is due to presence of electrical energy. अगर इलेक्ट्रिकल एनर्जी नहीं है मतलब लाइट ही नहीं, इलेक्ट्रिकल एनर्जी नहीं, लाइट ही नहीं, तो एसी कहाँ से चलेगा, फ्रिज कहाँ से चलेगा, आपका मोबाइल कहाँ से चार्ज होगा? So all this kind of, that is the energy which is associated with electric current is known as what? Electrical energy. So let us see the definition. Simple definition is there. So now here we know very well, we know that the flow of electric current, अगर बल्ब में से जाता है तो बल्ब क्या होता है? ग्लो होता है. फ्लो ऑफ इलेक्ट्रिक करंट थ्रू द वायर से फैन में जाता है तो फैन क्या होता है? रोटेट होता है. वो इलेक्ट्रिक थ्रू द वायर, अगर इलेक्ट्रिक बल्ब रिंग इलेक्ट्रिक बेल में जाता है तो इलेक्ट्रिक बेल क्या होती है? रिंग होती है, मतलब बजती है. तो वी नो दैट द फ्लो ऑफ इलेक्ट्रिक करंट causes the bulbs to glow, fans to rotate, electric bells to ring, etc. There are a lot of examples which are related with the electric current, and energy associated with electric current is called electrical energy. Then you will study in 12th standard in chapter 1, chapter 2. There are certain laws like Coulomb's law is there, Charles Austin Coulomb is there, then there is a Maxwell's law is there, there is a Ørsted's observation is there. There are so many laws and observations you will study. They are studying, what studying? So there are certain laws governing the force of attraction or force of repulsion between the electrical charges. तो चार्जेस के बीच में लगने वाला फोर्स ऑफ अट्रैक्शन क्या है, फोर्स ऑफ रिपल्सन क्या है, इससे रिगार्डिंग लॉज दैट यू विल स्टडी इन द 12th स्टैंडर्ड, एज वेल एज बिटवीन इलेक्ट्रिक करंट कैरिंग वायर. दो करंट कैरिंग वायर है, सेम डायरेक्शन में जाता है, दोनों में से, तो देयर इज अ फोर्स ऑफ रिपल्सन इज देयर। लेकिन ऑपोजिट डायरेक्शन में जाता है तो देयर इज अ फोर्स ऑफ अट्रैक्शन इज देयर। तो इसका भी लॉ है, तो दैट यू विल स्टडी। तो देयर आर सर्टेन लॉज गवर्निंग द फोर्स ऑफ अट्रैक्शन और रिपल्सन बिटवीन द इलेक्ट्रिक चार्जेस एज वेल एज करंट कैरिंग वायर्स। अब अगर हम बात करें कि यहाँ पे शहर में रहने वाला पर्सन बराबर पर सेकंड कितनी अमाउंट ऑफ इलेक्ट्रिकल एनर्जी यूज करता है, तो एन अर्बन इंडियन हाउसहोल्ड कंज्यूम्स अबाउट 200 जूल ऑफ इलेक्ट्रिकल एनर्जी पर सेकंड ऑन एन एवरेज। बी रिमेंबर, तो ये इलेक्ट्रिकल एनर्जी। रेस्ट ऑफ द एनर्जी वी विल डिस्कस लेटर ऑन इन द नेक्स्ट लेक्चर।